All right, review first semester here. Use the figures below to find the following measurements. Alrighty, so angle Y and angle Z. Now look, if you see two equal sides, what do we call that? Isosceles. And our isosceles theorems tells us that if we have two equal sides, then across from them, we have two equal angles. So that means this would also have to be 74. So angle Y is 74 degrees. And then Z, we know that inside of a triangle adds up to 180 degrees. So let's add up those two angles. 74 plus 74, we get 148. And then we have to subtract that from 180 to get the missing third side, and we should get 32 degrees. Number 2. Okay, we want to find WYZ. W to Y to Z is out here on the outside. So if this inside angle is 29, and this is called a linear pair, we know a straight line is 180 degrees. So we do 180, take away 29, and we get 151 degrees. XWY. X to the W to the Y. This angle right here. Well, I know two angles in this triangle, 90 and 29. So just like number 1, I add up the two I know. I get 119. And then I subtract that from 180. And I get 61 degrees. VWY. V to W to Y is right here. And remember, like we learned, or like we did right here, straight line is a linear pair, and a linear pair adds up to 180. So you can subtract 61 from 180, and we get 119. Number 3, which of the following produces a graph that is perpendicular? Okay. Well, first, let's find this equation. Here's a point. Here's a point. Let's figure out that slope. The slope of this one is up 2 over 3. So we have 2 over 3 as a slope. Nope, that's not right. This is actually not on the point. It's a little bit below. Okay, it's kind of easier to see here. See how it's not exactly on the grid? So, the next point really on the grid is right around here. It's not focusing for some reason. Okay. Well, so instead of going up 2, it goes up 1, 2, 3. It goes over 1, 2, 3, 4, 5. So really, this is 3 over 5. Okay, so if we want it to be perpendicular, so remember, perpendicular means what? Opposite, which is the plus minus sign, and then reciprocal, which means you flip it, slope. So since this slope is 3 over 5, it's going to become negative, because positive goes to negative. 3 over 5 flips to 5 over 3. right? So which of these equations has negative 5 over 3 as a slope? It's got to be this one right here. So B is perpendicular because it has an opposite reciprocal slope. Cool. There we go. Classify each pair of linear equations as parallel, perpendicular, or neither. So 3 over 4, 4 over 3. It does flip, but it does not change the sign. So this is not perpendicular, it is neither. Okay. It's got to be both opposite and reciprocal. Letter B here, negative 5, 1 over 5, negative 1 over 5. Those match. Parallel. Okay, negative 1 over 3 and a regular 3. If you remember our invisible math, 3 means 3 over 1. So did the sign change? Negative to positive? Yes. Did 1 over 3 flip to 3 over 1? Yes, that is perpendicular. Okay, letter D, positive 3 over 2, negative 2 over 3. The sign changed, the fraction flipped. Those two changes are perpendicular. Cool. Now, number 5, what are the coordinates of midpoints? Okay. Now, I'll tell you how to hack this thing. Okay, negative 7 to 3. Okay, if you count that horizontal change, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a horizontal change of 10. So what's half of 10? Oh, 1, 2, 3, 4, 5. Go halfway exactly, straight to the line. Boom! The midpoint of DE is negative 2 comma 0. Now, the other way you could have done this is you add up the x's, negative 7 plus 3, divided by 2, and you add up the y's, 5 plus negative 5, over 2. This gives you negative 4 divided by 2, which is negative 2. This gives you 0 divided by 2, which is 0. Boom. Whether you use the midpoint formula or you just intuitively cut it in half, either way. So let's just use the midpoint formula for the rest of these so we can be consistent. Okay, 3 plus 7 over 2. For EF, 5 plus negative 5 over 2 is 5 comma 0. 1, 2, 3, 4, 5. These points are like a smidge off, okay? 5 comma 0. And then DF, if it's horizontal, you can just cut this thing in half. So from negative 7 to positive 7, that's 14. Half of 14 is 7. If you go 7 over, you're right here at 0 comma negative 5. So you can do it graphically, or you can use midpoint formula intuitively. It's up to you. Cool. Number 6. Say whether or not each set of links would form a triangle. Do you remember, to tell if something is a triangle, it has to be the two smaller ones. They have to add up greater than the third side. Okay, so again, A plus B, the smallers, has to be greater than C, the longest. Okay, so 3 plus 5, 8 is not greater than 9. That's a no, sir. Okay, the smaller ones are 16 plus 16. 32 is greater than 17. Yes. Okay, so 3 plus 5 equals 8. Greater than 9 and 32 greater than 7. Yep. 5, 5.5 plus 2.3 is 7.8. Is that greater than the third side, 7.7? Yes. Okay, smaller ones here are 7 and 4, not the first two this time. 7 plus 4 is 11. Is 11 greater than 11? No, it cannot be equal. Okay, 10 plus 8, 18 is greater than 16. Yes, sir. And then 13.25, is that greater than 13.25? No, sir. That is not, that is equal. Okay, next page. Okay, once again, a triangle adds up to 180 degrees on the inside. That's the triangle sum theorem. So let's add up all these values. So we got 4x plus 30 plus 9x minus 5. And people forget, but don't forget this one right here. This means 90. And it equals the triangle sum of 180. Let's add up all these x's. 4x plus 9x is 13x. 30 minus 5 is 25. Plus 9 is 115. That equals 180. Get rid of this loner, minus 115. And you get 65. And then divided by 13, x equals 5. Cool. Now it asks us for angle y and angle z, which are both expressions. You're just going to replace x with 5 for y, and replace x with 5 for z. So 4 times 5 is 20 plus 30. That's 50 degrees. 4 times 5 is 45 minus 5 is 40 degrees. So 50 degrees, 40 degrees. Cool. 8 through 11. Identify the right scalene triangle. So I'm looking for right, which I only see here and here, A and F. But scalene means all the sides are different. So F cannot be it because it's 2 equal sides. 3, 4, 5. Letter A is right scalene. Number 9, identify the equilateral triangle. Equilateral, all equal sides. The only one with 3 equal sides I see is letter C, no pun intended. Number 10, we need an acute isosceles. So let's look for isosceles, 2 equal sides. That would be B, E, and F. So out of these 3, which one has all 3 acute angles? Let's see. So if this is 25, 180 minus 25 is 155. 155 divided by 2 is 77.5. So now I can see that each of these angles is each of these angles is 77.5. They're all less than 90, so B would be acute. And obtuse isosceles would be E, because obtuse is greater than 90, 2 equal sides, so it'd be E. Cool. Number 12. When I see equal sides and I'm trying to find the value of x, set equal things equal to each other. 5x plus 3 equals 6x plus 1. X is on both sides. You want to get rid of the smaller x, so minus 5x. 3 equals 6 minus 5 is 1x, which is just x. And then you can get rid of that loner 1 by subtracting 1, and you get the x is equal to 2, or 2 is equal to x. Okay? All right, 13. What types of line are M and N? Okay. Well, we call them parallel lines. Okay, we try not to just say it because it looks like it. But it's supposed to be. Okay. Okay. And then A and B and D. So if this is 120, do you remember the zag rule? 120 here, 120 here for C, 120 here for B, zigzag zig, and then 120 for G. All the obtuse angles have to match if they're parallel lines. And then the other 4, we subtract that from 180. We find the supplement because they're supplementary. So 60 will have to be here, 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 here. E and H are also 60 because they're acute and they're in a zigzag. So A is 60, B is 120, and D is 60. Cool. Now, 14, use the figure above, name the following pairs. Now you have to name these pairs, A and B, next to each other, making a line. Like a pair of angles making a line is a linear pair. H and A. Do you see how they're on different sides of this transversal T? Okay, so they're alternate and they're outside the parallels, so that's alternate exterior. Cool. A and E, okay, they're on the same side, so they're kind of same side, but one's in and one's out. So that's that weird one that we call corresponding because they're in the same spot, shifted down the transversal, one in, one out, same side. B and C are at one intersection, one in, one out, but it's really what I would say across from each other and congruent. Those are called vertical angles. D and E are in between the parallels, but different sides of the transversal. Alternate interior, in between the parallels. B and H outside the parallels on the same side of the transversal. That's same side exterior because they're outside of the parallels. The only one not labeled here would be something like C and E, same side interior. All right, number 15. Now look, obtuse, not obtuse, acute. Do not set these equal. These are supplementary when they're same side exterior. They're supplementary. So instead of setting them equal, you do addition, 145 plus 2x minus 15. And that has to equal 180, okay? So the only x is 2x, but the 145 minus 15, what is 145 minus 15? And that gives you 130, okay, equals 180. Subtract 130, 2x equals 50. Divide by 2, and x equals 25. Okay, non-matching angles add up equal to 180. Combine like terms, get rid of the loner, divide. 16, alternate interior angles, right? Alternate interior are congruent. You can set them equal, okay, because they are the same. So 3x plus 2 equals 2x plus 17. X cannot be on both sides, so let's go to the smaller x, minus 2x. 3 minus 2 gives you 1, x, which is just x, plus 2 equals 17. Subtract 2, and you get x equals 15. Cool? Number 17, 18, and 19. All right. Do these triangles exist? Okay, well, the triangles exist when it comes to angles. Okay, so they add up to 180 degrees, right? So 5 plus 4 plus 3, I mean, we can just Desmos this real quick. 5 plus 84 plus 33. 58 plus 26 plus 96. 46 plus 17 plus 77. All right, so the first one does not add up to 180. That's a big old no, sir. That equaled 212. But the next one is a yes because it equaled 180. Good job. And then the last one equaled 140. That is not a triangle. Okay, it's got to add up to 180 degrees. Okay, which of the following is the length of F and D? F to D. So F is -3, +3. D is 0, 0. So if I'm using the distance formula, it's going to be square root x2 minus x1, right? So 0 minus -3 squared plus, and the y2 minus y1, 0 minus 3 squared. Okay, you can type all that in one step. All right. Type it all in. I end up getting 4.24, which is about 4.2, which is B. Okay. Just be careful with your negatives and subtracting signs. Okay. 21. If RST is equal to XYZ, then RS is congruent to which of the following. So you don't even need a picture. No picture needed for congruent triangles. Okay. First two letters are RS. First two letters are XY. It's too easy. Order matters. I've been saying this over and over and over and over, and the next day, and the next day, and the next day, and the next day. All right. Well, anyways, given that sun is congruent to tan, what can we conclude? First and third, SN, should match first and third, TN, and that ain't it. S, first letter, should match T, the first letter. That ain't it. T, first letter, should match S, the first letter. That ain't it. First two letters SU should match first two letters TA. That's it. Because why? Order matters. All right. ABC, DCE, okay? These are congruent by what theorem? Now, please remember, when you see an X, those angles across from each other are called vertical angles, and they are congruent. So I'm going to label it right here with two arcs, because I already see one arc on the triangles. And what are these three things in order? Arc is an angle, tick mark is a side, arc is an angle, angle, side, angle. It's too easy. All right. Here, when they're touching, okay, we have what are called adjacent sides. They are congruent, or I say touching sides. You got to put a tick mark here. Okay, AB and AD are supposed to be congruent, so I can put two ticks on AB and AD. And then it says DCA is congruent to BCA. Now, here's the tricky part about this. It looks like angle side side, or SSA, which we can't do, and it's only HL if it's right. And you know what we don't know? It doesn't say that it's right, so we don't know about this. So I would just say none. We don't know. Okay. 25. Name that angled pair. Okay. Well, first thing, we don't have to do any solving. We just know that these two angles are across from each other. And like we said earlier, across is called vertical angles. Okay. Now, for X, we need to set those vertical angles equal to each other and solve them. Okay, and here we go. 5x plus 6 equals 8x minus 3. Smaller x is 5x, you subtract that out. 6 equals 8 minus 5 is 3x, bring down minus 3. Get rid of the loner minus 3 by adding 3. 6 plus 3 is 9. And you divide by 3, and then 9 divided by 3 is x. Cool? Now, when they're next to each other making a straight line, that's a linear pair. Do not set these equal. Straight line, vertical linear pair are supplementary. They add up to 180. So this time you're going to add them up to 180. Combine like terms. 3 plus 2x is 5x. Bring down plus 25 equals 180. And now you can get rid of that loner 25 by subtracting 25. And you get 155. Get rid of that coefficient by dividing, and you get 31 for x. Cool? 29. Okay. We know they're similar. Okay. So JL 1 and 3 matches OQ. So those are corresponding. Second and third. Those are corresponding. So we're going to go left to right as a fraction. 9 over 99. Those are corresponding. equals, left to right, 10 over x. Then what do we do? Cross multiply. 9 times x is 9x. Write the equals. 10 times 99 is 990. And then that's the cross multiply. Now we divide, and we get 110 for x. Okay? 990 divided by 9 is 110. Okay? Now here's a ton of vocab. Okay? Let's talk about it. Part of a line that starts at an endpoint and extends forever in one direction, that's going to be called a ray. Okay. Straight path, no thickness, extends forever both directions as a line. Point in the middle is a middle point. Midpoint. Okay. Angles that add up to 180 degrees. Okay, are a linear pair. Well, linear pairs if they're adjacent, but even if they aren't adjacent, you call them supplementary because 180 is supplementary. Lines that intersect and create a right angle are perpendicular lines. Name a location and no size. Location is a point. Part of a line consisting of two endpoints and everything in between. So two ends is a segment or a line segment. When angles add up to 90, remember 90 and 180, these are the confusing ones, but 90 is complementary because it's the right thing to do, which is a 90-degree angle. And lines that never touch are parallel. They don't touch. Cool. All right. The sums of sides A and B is greater than the longest side. That is the triangle sum, not triangle sum theorem. Okay. Triangle inequality. Where we at? There we go. S. A triangle with three acute angles is an acute triangle. Very acute. Three congruent angles is equiangular. Three congruent sides is equilateral. No congruent sides is scalene. One obtuse is obtuse. Two remote interior add up to the exterior angle is the exterior angle theorem. One right angle, right triangle. Two congruent sides, two like your eyes. Isosceles. Process of elimination, but we know all three angles add up to 180 because that's the triangle sum theorem. Please study this and be ready for your final exam this week.